So in continuous random variable, we will not be seeing P of X. It will always be F of X because there will be no tables, okay, for computation. We're always working within an interval. Okay, good. Now, the probability of the process at a point, at one single point, will always be equal to what? 0. Okay, good. Now, there are key properties of the PDF which we have to take note of. That the probability of X, okay, can always be greater than or equal to what? 0, given X in the real number domain. Okay. Then point 2, the integral of F of X, or the integral, the summation, continuous summation of the probability function, okay, over the domain is equal to 1. Then we have point 3. The value of F of X when equals to 0 means that X is not possible in the what? In the domain. Now, let's move on and look at a comparison between what we have just looked at and the discrete random scenario. Okay. So if you look at the table we have here, it makes it quite simpler to compare. So the first thing you take note of is the fact that in a discrete random variable, you are always giving the values of X as maybe 0, 1, 2, 3, 4. Okay, means it's a discrete random variable. In a continuous variable, you always have intervals. So for example, you'll be told X is greater than maybe 20 or X is greater than 5. But probably less than what? 10. Okay. So every value between 10 and 5 is part of what? Of X, or X can take on any real number value between what? 10 and 5 within that domain. Good. Now, that's the first point. Then the second point, the second point is a comparison of the properties for the PMF, that's for the discrete case, and then the PDF for the continuous case. The first point is, instead of writing P of X, like I said, you find F of X. Then we said that the probability of an event is always greater than or equal to 0 for all I. In the same way, the probability of F of X will also be greater than or equal to what? 0. Then the next point is the summation of P of X is always equal to 1. In the PDF case, it is integration, because integration is continuous summation. Last time I told you that when we are adding continuously, then what we are doing is we are integrating. Okay, so continuous summation is integration. So you can see that the summation sign here changes to integration here. Okay, and then this F of X is still the PDF, the P of X. You understand? But because it's integration, we have to integrate with a variable, with respect to a variable. So that would be F of X dx is equal to what? 1. Okay, good. Then we also said that if the probability of X is equal to 0, then it means that it's not possible for X to occur in the domain, or X is not part of the real number domain or the domain of X. Okay, so in the same context, we can also write a CDF for a continuous random variable. The only difference here is because it's continuous, summation will change to integration. And anytime we are integrating, we integrate from lower bound to upper bound. So in this context, because we are summing to a given point x, we integrate from the lower bound, which is negative infinity. So what you are seeing there is negative infinity to the upper bound, which is what? X. Okay, of f of t with respect to what? With respect to dt. So we always integrate from the lower bound to the x value to get the CDF. Okay. And sometimes we are interested in the cumulative distribution between 2 points A and B. So over there, we integrate from A to B, the probability function f of x dx. So you take notes of that. I'm sure you were jotting down some notes whilst I was explaining to you. Okay. Let's continue. So we are going to take down the properties of the continuous random variable as well. And then we will solve some examples of them. So quickly write down these formulas for me. The CDF, which is given by this formula, write this formula down. Then write down, this is not variance, this is mean. So in order not to confuse you, let me just clear variance from here. Okay. So the mean is this. So write that formula 2 down at your end. Please make sure you are writing. So this is the second formula. And then the variance will also be given by this formula here. Okay, they are all the same, but we'll work with this more. So we have var of x equals to this. And then the fourth formula is what you have in blue here, okay? So write down the four formulas. Write the four formulas. Make sure you write it at your end. Yeah, are you done with the formulas? If you are done, just give me a yes on the chat page. Okay. Okay, so I'm sure we're all done. We want to try this example here. Okay, we asked to find the expectation of this given distribution here. I skip example one, okay, for a reason, but we'll go back to that briefly immediately after example two. We want to find the expectation, okay, of x given the probability function, okay, f of x, which is this. Now, the first thing you notice is this is an interval. X is greater than 100, meaning all values which are greater than what? 100. Okay, so 100.1, 100.2 are all greater than 100. Okay, so you take note of that. Now, okay, so that helps us to know that we are dealing with what? A continuous random variable. Then again, expectation, we know from the formulas you wrote, we said that the expectation is what? The expectation is given by the formula u of x, okay, is, we say we have the integral, okay, from the negative infinity to infinity of what? X times f of x, okay, dx. That gives us the expectation of the process. Now, let's put in the values and see what we mean by that. Now, coming to the negative infinity, this is the lower bound or the smallest value in the domain. And then this is the upper bound, okay? Or the largest value of the domain of x. Let me put it that way. Now, when we come to this function here, or the given domain, we said x should be greater than 100, okay? So the smallest value will be what? 100 here. But we are told that s is, even though we are told s is greater than 100, we've not been given any value for which x is also less than, okay? So it means that obviously s goes all the way to what? To what? Positive infinity, okay? So it means that we are going to get the upper bound or the largest value in the domain as what? As positive infinity. Okay, then we bring our x here. We are going to bring the x times, now what is f of x? F of x has been defined here, okay, to be what? To be 20,000 over what? Over x cubed, okay, with respect to what? Dx. So once we've written this, we know first the 20,000, we can bring it out, okay? Per our rules of integration, we can bring the 20,000 out. Then x can go into x cubed, x squared, okay? So it means that the equation can reduce into the form what? Into this form, which we are seeing here, okay? So when we do the cancellation, then we have this form. So from this form, I also want to expand it further before you get the final answer. So from this form, this will give us, we can bring our 20,000 out. So this will be 20,000, okay? Then the integral of 1 over x squared dx, okay, from 100 to infinity. Now 1 over x squared is the same as what? X raised to the power -2, okay, good. So which means when we are integrating, per the rules of integration, you always have to add 1, okay, and then divide through by the resultant. So -2 plus 1 will be -1. You understand? So when we integrate 1 over x squared, it means we'll end up getting what? We'll end up, this is the same as x raised to the power -1 over what? -1. Okay, good. Which is the same as what? Which is the same as -1 over what? X. Because this will be x raised to the power -1 is the same as 1 over x. Okay, good. So which means when we integrate what you have over here, we'll get 20,000, okay, into bracket what? -1 over x. Then we put the limit of integration there. That will give us what? This will be 100 to what? To infinity. Okay, good. 100 to infinity. So let me go to the next page, and then we continue that on the free page. So which means that we are supposed to evaluate, okay, substitute the infinity and the 100 into this expression here. So I'll go to the left side and do that. That will be 20,000, okay, into brackets 1 over -1 over what? We're going to put infinity in there. So -1 over infinity minus, okay, -1 over what? 100. Good. I taught you definite what? Integral last semester. So this will give us 1 over infinity will give you what? 0. Okay. Any number divided by infinity will give you 0. Then negative times negative will be positive. Then we have 1 over what? 100. Okay, good. Now you still have your 20,000 outside the bracket. 0 plus 1 over 100 is what? 1 over 100. Okay, times the 20,000 outside the bracket. So when we divide 20,000 by 100, 2 zeros will cancel out this, and we'll be left with what? We'll be left with 200 times 1, which is equals to what? Which is equals to 200. So the expectation, okay, of the given function which we had earlier, let me go back to that question. So the expectation of the process of this function here gives you what? 200. Okay, so that is the 200 which was initially written over there. Okay, so observe it carefully, and then if you have any questions, you can ask. Observe the solution carefully. If you have any questions, then lift your hand up and let me allow you in. Yeah, Linda, any question? Linda, do you have a question for me? If not, I'm moving on. Any question from you, class, before I move on? Okay. So in the absence of any question, I'm moving on to the next question. Okay. Now, let me pause this. Yeah, Matthew, your hand is up. Matthew, your hand was up. Yeah, Linda. Linda, your background was very noisy. That's why I muted you. I think I saw one Matthew's hand up. Okay, so Linda, if you have a question, you can raise your hand, else I'm moving on. If there is a question, please raise your hand. Else when I move on, I'll not come back to it. Okay. Yeah, so that's for this example. I think you're all clear. I'm not getting any questions on that. Now, for the next example, I'm contemplating as to whether we should touch on it. Okay, but ideally we should have been able to touch on it. Let's just touch on it. And when you are not okay, you go back to your rules of integration, which I taught you last semester. Okay, you needed it. It was an integral part of your course outline. So you need it for this course as well. Okay, now, just like in a discrete case, you are given the probability distribution and you are given some unknown value k, and you are told to find the value of k. Okay. In the same way, you can also be given an unknown constant k in the continuous distribution and asked to find the value. Okay, so in this case, what you do is the rule is the summation of what? The probability distribution should be equal to what? 1. I'm trying to make it very simple. But summation with respect to what? With respect to what? X. Okay. And then once again, because we are summing continuously, we should be starting from a point to a point, which will be the lower limits. The lower limit here will be what? 0. And the upper limit will be what? Will be 10. Okay, good. Then again, the question is, what is f of x? F of x has been defined as what? K times e raised to the power what? Negative 0.1. So it means that we can also write 0 to 10 of k times what? E raised to the power negative 0.1 x with respect to what? Dx is equals to what? 1. Okay, if that is the case, k is a constant, so we can bring it out. So let me, then I have k out, integral from 0 to 10 of e raised to the power negative 0.1 x dx, okay, equals to 1. Now, when we integrate e raised to the power x, what do you get? Anytime you integrate it, it's going to be what? You have to come and differentiate the f of x up here, okay, and multiply with it. So if you remember your rule from last term, this will be negative 0.1, okay. So, okay, so sorry about that. We are talking about integration here, okay. So it's going to be divided by what? Negative 0.1 instead of multiplying with negative 0.1. So let me clear that. So we are going to have e, okay, raised to the power negative 0.1 x, okay, over what? Minus 0.1, okay. Then you have to bring our limits of evaluation, which will be 0 to what? To 10, okay, good. So these are the steps. Now let's go and look at the solution of it. I think I've explained the steps clear now. But don't forget, it should always be equal to what? 1. Okay. So let's go to the next slide for the solution of it. So once we get to the next slide, I think that has been well explained here. So in the next slide, all we are doing at this point is you have to substitute the limits of integration. Okay, that will give us what? This is k here. And then you substitute the 10 and the 0 in, okay? So that is what we are getting as negative 0.1 times what? Times 10. So that will be E. Let me just put it here. This is it. So E raised to the power negative 0.1, then X is 10. So you put it here as an exponent over negative 0.1. Then minus E raised to the power negative 0.1. This time X will be what? 0. The lower limit is 0. Okay. So you put it here. This is let me correct that. So this is 0. Okay, so this will be 0. Good. And then once you do that, negative 0.1 times 10 will give you 1. And then 0.1 times 0 will give you 0. Okay. So when you take your time to do the calculation on your calculator, okay, you realize that e raised to the power negative 1, okay, over minus 0.1 will give you negative 3.678. Then e raised to the power 0 will be 1. 1 divided by 0.1 will be 10. Okay, but because there's a negative here, it will be minus 10. Then when you add these two, negative will be positive. So when you add the two, you get 6.32. Okay, then multiply with the k and then equates to 1. So if you want your k, you divide both sides by what? 6.32.